So now we're going to jump over to the nutrient film technique. Okay, that's NFT system. That's what you'll see it abbreviated as everywhere because nutrient film technique takes a while to say. The method and how it works, well, plants are placed into small channels at an appropriate spacing. Small plastic channels, almost looks like a rain gutter, okay? And we'll see some pictures here in a minute. A shallow stream of water is flowed from the higher end of the channel to the lower end where the water exits into a master collection channel and is recirculated to the sump. So water flows in one end, it goes downhill, drips out, goes back to the sump and is recirculated. Very, very simple. Okay, here's some design criteria on a nutrient film technique system. The channels should be no longer than 30 feet or 10 meters in length unless we have multiple injection points going down the length of that channel and advanced draining strategies are employed. So what that means is after this distance, we're going to have removed enough of the nutrients from the water that we're going to get nutrient deficiencies in the plants further on down the run. So we either need to have another inlet with fresh water coming in at that point and start draining the nutrient drain system water out, or we just keep the channels to this desired length. I've seen channels over 100 feet in length, so you can definitely do that, but I think it's a lot harder to work with. 15 to 20 foot in length are much more manageable and much more easier for, say, a single worker to be in there working with. When you get above that, you really need a couple people to work around and move the channels around. You want to buy channels that have zero light penetration when they're plumbed. And that's very important, okay? A lot of the earlier days NFT channels had open ends where you would just stick a tube in and you can see the water rushing in. You would have open ends on the bottom where the water just drained out and fell into an open top pipe. But everywhere that you've got an opening, you're going to get algae growth. And that algae growth is something you're going to have to clean. So if you have everything covered up, you're not going to have much work at all to clean and maintain and keep these channels running. If you have an open system, that's weekly or multiple times a week maintenance that has to be done to remove the algae and the fouling to keep everything running properly. That's why sometimes cheaper is not always better. You might find some channels that are $5 cheaper per channel, but they have a lot of light penetration. Well, how much labor is that going to take you for the life of that system? It's a lot more than $5. So design flow rate to each channel, I'd say approximately 0.2 liters per minute. Within the channel has an optimum slope, so how much we want it to slope downwards, and that's of 1.5%. So about 1.8 inches over a 10-foot length. All right, not much. You don't need much to let the water run. We're not looking for raging rapids. We're just looking for enough so that gravity will keep this water flowing at a slow, consistent film on the bottom of that channel. Long runs can get depleted of oxygen and nutrients, and they can also have pH swings and temperature fluctuations. Because there's such a thin film of water in these channels, that's why it's called a nutrient film technique. A thin film of water just covers the bottom of these flat channels, and because of that, it's real easy for the temperature to change. So if you've got a blazing hot day outside, and say these are placed outdoors, and the outside temperature is 20 degrees hotter than your sump temperature, it's going to heat that water up quite a bit because there's just so little water and so much of the surface area is exposed to that hot air. So make sure that the water is sent through a biofilter, completely stabilized for best results. All right, that was a huge problem that we had at Green Sky Growers when I used to manage that operation, is the NFT system shared a common sump with the water coming post drum filter. Okay, so the water would come from the fish tanks through the drum filter into a sump before it would go to a biofilter. Well, that sump is where we would actually pull the water from and send to the NFT system. Now, don't blame me for this. I did not design this system. I just fixed this system. What does that mean? That means we have a lot of high ammonia water in there that has not been oxidized. So we had an extremely large amount of nitrifying bacteria growing on the inside of the pipes, going into the manifold and in the small feeder tubes going into each channel. And that led to us having to clean that with a pipe snake every few weeks to make sure it would not completely clog up and foul. And for a 1-inch line, when you opened it up after a few weeks, there would be so much biofilm that you would actually only be able to see about a 1/2 inch through the middle of that 1-inch line. So significant reduction in flow. And what happens to any of those solids if they break off? Well, they either clog something up further down the line, or they are shot into that NFT tray and they clog up in the root system. You get a bunch of bacteria, dying bacteria right in the root system, and it leads to root rot. So it was horrible. It looks beautiful in pictures, but that was a big problem with the design of that system. So always send this water through a biofilter and have it stabilized and oxidized first before you move it to your sump that's going to be circulating through that NFT system. And in this slide, we will see there's actually tomatoes on the left and there's some squash on the right. And these are kind of some makeshift NFT channels. These are from years and years ago. And this is 3-inch PVC and 4-inch PVC. And I basically wanted to throw this up there to show you that larger crops can be grown in NFT channels. But bear in mind, PVC isn't a true NFT channel. Because of the curvature, we don't get a flat stream of water like you do in a flat NFT channel. You get a little bit deeper water, and that kind of goes against the principle where we're supposed to have this thin film, and that's it. So, you know, be that as it may, this is the only picture I had of fruiting crops in an NFT style system, so I wanted to throw it up here for you. Here's a system at Green Sky Growers, and you can see the long array of NFT channels. They're at a small slope going down this way towards us, towards the fish tanks, and they're fed at the top here in the back by a feeder line. The water comes through and it drips out of the end of the open channel here into this open drain line. Okay, bad design. That's not great at all. You can see the color of the roots here is actually pretty black, and that's from algae and from bacteria that have made their way through the line and clogged up the root systems there. And you can see that the drain line here is open, so that gets covered with algae within a day or two. And every week we had to do a major scrubbing to clean that out and make it look appealing again. And so you didn't get any clogging and overflowing of that pipe. So this, you know, again, beautiful setup, but you can see these aren't the best channels, and this wasn't set up the best way. This is actually taken right before I came into the facility, so you can't blame this on me, but I thought there was a lot of things we could learn just from the picture there. And you can see in this channel, they're actually spaced every 8 inches. So there's a hole every 8 inches for the plant plug to go down into. And when you buy these, you can buy them at 8 inches, 10 inches, 12 inches, or you can buy, or 6 inches, or you can buy it blank and drill them yourself at your own spacing if you've got a different kind of crop that you're growing. So very, very easy to amend into your operation. Some of the pros here, the channels are lightweight, mobile, and food safe. So right off the bat, that's a great thing to hear when this is going to be holding all of your vegetables that people are eating. Lightweight, you can move them around, food safe. That's great. As far as lightweight, if you're doing something on a rooftop like this, it makes a lot of sense to use something like this over a deep water culture system. Okay, because you don't, maybe your roof, it has to support the weight that you're putting up there. And if maybe you know, you're looking at it and it's engineered to hold 10,000 pounds and you're well within that using NFTs, but if you were to switch over to deep water culture, it might put you at 80,000 pounds. So sometimes you got to look at this stuff and say, what's the decision? How much is it going to cost to re-engineer the entire roof of a building, or you know, use the NFT channels, okay? So think about that. They're light and they're good for vertical applications like that. Cleaning the channels between crops is very easy with a pressure washer or a scrub brush. Okay, pressure washer is when you're doing it yourself. Scrub brush is when you have a low-dollar employee or a child. Just joking there. Point is, a pressure washer is really easy to use. You can blast them out and clean them really quickly. If you don't have a pressure washer and you just have to get it done, by all means, you can do it with a hand scrub brush. You're just going to spend a bit more time on labor and look at how long it takes you the first time you do it. Add that up over a year, see what your time's worth, and you could have probably bought a couple pressure washers by that time, okay? They can be used for many years. So inside a greenhouse, they could be used 10 to 20 years. After time, you will slowly start to get breakdown because of UV light, like anything else outdoors, but they last a long time, and a lot of them will come with a certain year guarantee on them. They're competitively priced. If we price NFT channels versus building a deep water culture trough or some of the other methods out there, Dutch buckets, etc., well, they actually are right in the same ballpark when we add up all the pieces and plumbing and structures to hold it. They're right there. So choose based on the application, not based on just price, because they're going to be right in the same ballpark. Okay, well, the cons. These are better suited for smaller plants, even though they do make larger channels for larger crops. Okay, and that's why I wanted to throw the tomatoes and the squash in there. People do cucumbers in them. And they make troughs or channels that are 12 inches wide instead of those 4-inch wide channels that you saw for the lettuce. And they're for larger rooted crops. But on the large scale commercial marketplace, you do not see hardly any commercial growers utilizing that technology, and I haven't personally seen competitive growth rates and studies showing how they compare to, say, Dutch buckets or other methods that are used for those larger vining crops. So not my favorite for larger crops, and larger crops have larger root systems, more water requirements, and power goes out, it's going to happen that much quicker. It's going to kill your crop. And that's what we're talking about right here. Power outages or clogging of the water line can quickly lead to crop failure. So if you're not checking those water lines every day, keeping things clean, processing that water first so you don't have nitrifying bacteria clogging up your water lines, if something like that happens, crop failure can happen quick. One of those channels will die in a couple hours. Everything toasts, you can't bring it back. And you're out that money. Plus the cost of the media, plus the time, plus your customers. If you can't deliver that week, that hurts you. So keep that in mind. This is risky if you do not have fail-safes in place, such as people on hand to watch this every day. Somebody in the greenhouse to do the checks every day on the equipment to make sure they're working properly and not clogged. Root disease can easily be passed to other plants in the same channel. It's such a thin amount of water that if you do develop Pythium or some other type of root pathogen, it will quickly travel between the different plants in that channel and spread throughout the root systems, and you'll lose the entire channel of plants on most cases. You get a lot more heat transfer with channels because of the thin material and the fact that it's such a thin layer of water that has a lot of surface area contact with the air outside, the ambient air in that channel. More heat transfer, slower growth in hot climates. And again, I mentioned that earlier, side by side with the deep water culture system, same water temperatures, same air temperatures being higher than what we normally would want. Well, your deep water culture will heavily outperform the NFT system. So what I'm just trying to get through here is if you're not completely environmentally controlled, NFT can lead to more problems and not give you the growth that you're looking for. And it takes more energy to control the water temperature because we have, again, such a high surface area of water coming in contact with the ambient air temperature, and the fact that those channels are so thin and can heat up, we get a lot more heat transfer into the water column. Now, what does that mean? It means more energy to control the water temp. So we need a bigger chiller to actually keep that water at our desired temperature level. Now, to calculate that, unfortunately, I don't have a chart for that because it's pretty complex, having to do with how much your heat gain you've got coming into those NFT channels, you know, according to the water volume. But what I would suggest is call up Aqualogic. They are a company that deals with chillers for hydroponics, aquaculture, aquariums, etc. Really good people, very knowledgeable. That's who we supplied some of the charts from earlier. And they will have a good idea on how to size that chiller specifically for your application. I can help you and oversize it a little bit to what I've done for me. But what I would do is, again, every day of the week, you're gonna have to buy a chiller anyways. Call these guys up. They've done this a lot. They work with the hydroponics industry, and they can give you a hard number that you can be confident will work. Because again, they're trying to sell you their product. They're going to make sure the number they give you is going to do the job. Varieties that work best, again, leafy greens, herbs, smaller, more compact plants and flowers, and short-term crops. You know, really short-term crops, something you can move, flip, get out, get a new one in. Those seem to work really good. I like watercress too. That's a great one for NFT. But as you can see, I'd focus on the smaller varieties with these types of channels. Vertical towers or stacks. You see some stacks that are made out of polystyrene square containers. The method and how it works. Plants are oriented vertically in a growing apparatus to maximize the use of ground space. Okay, so the thought is if we can take a 10-foot row this way and stand it up on end, we've got a lot less of a footprint on the ground, and we can use the vertical space to grow in. These are typically filled with perlite, cocoa fiber, vermiculite, several other types of medias, or empty when used as an aeroponic device. So they'll be empty and you'll have water just freely flowing through and coming in contact with the roots of the plants. They are watered from the top, and gravity allows the water to flow down through the entire growing medium and then be recirculated to the sump. So we pump to the top, flows by gravity down to our low point, and it's pumped back. And here are some of the vertical units that I worked with in one of the wings of Green Sky Growers. Here you can see giant basil towers going to the roof, and these would actually rotate 360 degrees slowly so that everything would get even light exposure and good air movement between the plants. The ones on the back here would actually move on a conveyor belt around the whole building for the same reason, and because it looks cool, and this was kind of more of a tourist attraction. So you can see this is one variety here, and again, you see the plants here, as they're small, they're planted in to each of the open spaces, and then as they grow, it fills up the tower. Pros, okay, you can fit more plants in the same space as traditional plantings utilizing horizontal oriented planting schemes. Okay, more plants up than flat. Better airflow around the plants. Because we get them up, you know, it's not, the airflow is not dampened by the first set of plants. It hits and slows down as it gets through. It actually gets an even exposure to that entire array of plants. It's definitely more attractive for tourism-oriented operations, and that's something to keep in mind here, guys. Everybody that wants to get into this business doesn't have to be a giant producer of food and make every dollar that way. I mean, farms nowadays are more popular as a tourist attraction than they are to farmers to actually farm. I can't tell you how many, I don't know, at this point it's probably been thousands of people I've turned down from visiting my farm because I don't allow visitors. But people week in, week out want to come see a farm in real life, in person. Something about that is really strange, that farms are an oddity now that we need to visit as an attraction. It's cool that we have that kind of appeal, but it's weird. It's strange that that's where society's at. So again, where that was leading to though is you can move into the tourism district and do just fine. Allow tours, make that part of your venture, teach school kids, bring in, you know, Boy Scout troops, make that part of your initial design, and guess what? That opens up a lot of other opportunities. And sometimes the numbers may work a little better when you start opening yourself to those other opportunities. It's not what I chose for my operation, but it could be right for your operation. Ease of harvesting, okay, I'd say they're easy to harvest because it's vertical, right? The whole idea is you don't have to bend so much, it's more in front of you. But as you saw in that last picture here, we had to have a 16-foot ladder to get up and actually harvest the stuff on the top of these verticals. So I can't say it's always easier to harvest because that was not fun. But if you do them within your reach zone and you only make them that height, then yeah, I think you could say that. Some of the cons, they're better suited for smaller crops. Okay, doesn't make any sense to grow a big giant crop up on one of those vertical units. It could get top heavy and fall over. It can shade other plants. It's not going to be good. If not planted correctly, the top plants can shade the bottom plants and cause uneven growth rates. Clogging issues if not properly cared for, okay? So if the roots are all growing in this mechanism, depending on the device you're using, you could get solids in there, different things happening, and you might get root rot, which can travel to the other plants. I think of these very similar to the problems that come up with an NFT system. You can have fungal issues if the water doesn't stay in the channel. So sometimes by splashing down with gravity, you get little bits of water that kind of squirts out of the planting holes in these channels, depending on, again, what type you're using. Too much water constantly on plant leaves leads to rot and to fungal issues. Varieties that work best, I'd say smaller vegetables and plants like leafy greens, lettuces, and herbs. Dutch buckets. Okay, so the method and how it works. A 3-gallon bucket is filled with perlite, cocoa fiber, or any other planting material, and fed from the top with a drip stake. So we have a pump, a line, the line goes into a small drip line, and then we put that into a stake to hold it right there at the base of the plant. The drain fitting at the bottom leads to a central drain line, a 1.5-inch drain line. It fits right under the side of this square bucket. And that flows back to your central sump. There's a small reservoir of water in the bottom of the bucket to ensure the roots stay moist between irrigations. So what happens is we flood this bucket, a small 3-gallon square bucket full of perlite, we flood it with water, and it will get about 1 inch of water in the bottom, and it will start to overflow and go out of the container. When we stop the flood cycle, that water is slowly used up by the plant and wicks up through the rest of the perlite as it's used up and as it evaporates. So at the time that water is used up in the small reservoir, we trigger another flood cycle. We drip irrigate the plants again, that restores the reservoir and gives us another 4 to 8 hours in between the next type of fertigation period. What does that mean? Means less energy out of that pump. It's only running, again, a few minutes a day. So very energy efficient. And Dutch buckets are one of the top ways that commercial growers grow cucumbers, eggplants, peppers, or tomatoes. I mean, this is, run of the mill. This is what they're going to use. And here you see a nice tomato greenhouse at the beginning stages as these plants are just going to start to fruit. The floor is all white. It's actually set on styrofoam. That's a styrofoam floor for insulation because these have a lot of heat transfer like an NFT channel. So we've got that insulated. And then we've got our main black drip line. You see the main irrigation line coming right down the center. A little drip stake coming off to each one of these buckets. And then at the bottom here, you can see a PVC line that runs right down the center. And there's it's a 1.5-inch line, and there's a fitting. You drill a hole and you stick the little end of the nub on this bucket right in that hole. So the water goes in the top, any excess drains out here and goes back to your collection area. But that's nice, clean setup, real easy. The Dutch buckets are $3 to $5 each, depending on where you buy them and the quantity you buy them. And this is a very clean, good-looking installation. Works great with aquaponics. Here are some Dutch buckets. You can see a little clearer. I know that last photo was a little grainy, but these are at Epcot here in Orlando. And you can see your normal 3-gallon Dutch buckets here, main irrigation line, drip line going up to the bucket, and then they're sitting on a 1.5-inch drain line that goes back. You've got cucumbers, and then in the back here, you actually have a giant Dutch bucket that they've made here, and those are what they grow some of their big eggplant trees and cucumber trees. And I'm talking, you know, cucumbers that have a 20-foot span, and they're raining down because of cucumbers because of the way that they've trimmed and trellised them. Well, they use a homemade larger bucket for that. So you can make these yourself. You can make them out of 5-gallon buckets. A lot of times the cost of the bucket is very close to what it will take you to make it yourself. So the pros, these are simple to set up, very simple to set up, as you saw. We can grow a wide variety of crops, though we generally only see larger crops being grown in these. Because of the cost to set up and everything, you usually don't see a lot of lettuce, smaller crops being grown in them, but they can be. The reservoir at the bottom of the bucket allows a bit of extra insurance in case of power outage, and they're reasonably priced. The cons are upkeep on equipment is timelier. Okay, similar to an NFT system, we've got a small feeder tube, and that's timelier because we have to keep it unclogged and maintain that. Media needs to be periodically replaced as we change crops, we pull out big root systems. A lot of that perlite or whatever you use is going to be enveloped in the root system. So we're going to have to replace that periodically. Clogging can be an issue if not properly cared for. So if we don't provide the proper filtration to that water before it's sent to these, just like we talked about in the NFT system, it can cause us problems. And temperature fluctuations can cause major issues in non-controlled environments. So if you have these, say, outside, and in the nights they're dipping down into the 50s and you're trying to grow tomatoes, you're going to have huge problems using Dutch buckets because it's such a thin wall that it's going to want to, you know, equilibrate with the temperature outside, and tomato roots don't want to be at 55 degrees. So if you're using this in a controlled environment, great. If you're not, something you really have to watch out for is insulation of that bucket because you get wide temperature swings, and that's not going to be good for plant growth. Varieties that work best are, again, tomatoes, cucumbers, peppers, eggplant, okra, melons, flowers, sunflowers, roses, you know, anything larger that you're going to be growing, they do great in these systems. I think I've even seen people grow hops in them now. Now we move on to perlite, cocoa fiber, and rockwool slabs. Method and how it works. A sealed bag is pre-filled with the media of your choosing. A cut is made in the bottom of the bag for drainage and in the top of the bag so that you have a place to plant your seeds or plants if you already have them planted in something and you're transferring them onto the slabs. Seeds are either started directly in the slab or in a starter cube where they're later moved into a block, then set on top of the slab. So we start them in a little starter cube of rockwool, cocoa fiber, whatever our starter medium is going to be. And then when we transfer them and step them up the first stage, they sell little blocks that have a hole pre-cut out in the middle that our plug fits right into. So that's very commonly done with rockwool. And cocoa fiber, in perlite, a lot of times a smaller pot is used at first, and then that is set onto a larger slab to continue growing. The slab is irrigated from the top by a drip stake, very similar to a Dutch bucket. The water saturates the slab, and farmers will generally use one of two methods. Water until you see it start to drain out of the drainage holes cut in the bottom of the slab, then shut off the water and let the excess water drainage out of the bottom of the slab go to waste, so it just runs off and drains off to nowhere. Or the slab is set on a gutter and all of the excess water coming out of the bottom of the slab is returned back to the sump. Now, again, because we're trying to reuse our water, we are always going to use that second manner. So we set all of these slabs up above a drainage sump. So like very similar to an NFT tray, but we would make a channel so that they can drain completely and that water can be recirculated back to a collection sump. This is a close-up picture of a cocoa fiber slab, and they're usually compressed, and then once you add water, this is going to swell up, and that's after the water has been added to the coconut fiber slab. Common size on a slab is going to be 36 inches long, and then it's going to be 6 inches by 2 inches, or 6 inches by 4 inches. So those are usually the slab sizes you see. And this 4 inches is very common. I think 2 inch I spoke of is before you add water on the coconut fiber, because 4 inches is where it's at. But these are strawberries, very common. You can see these are lifted up off the ground. You've got your coconut fiber slab here, and you've actually got a drainage gutter below it to capture the water and allow that to move on. And some beautiful strawberries being grown here. Here are some rock wool slabs, and this is just a, again, old home system to show you. It's the only thing I had that was mine that had rock wool in it. But we've got rock wool slab laid into this vessel. This just allows it to drain completely and goes down to a sump that was beneath it. And a couple cucumber plants in there. We start them in the blocks. The blocks are set on the slabs, and the roots grow down through the blocks into the slab and fill that out. And you can see we've got a lot of healthy cucumbers on that plant. The pros are that it's very easy to set up, just like Dutch buckets, just like NFT systems. So these are really easy to set up. You have an ability to grow a wide variety of crops. The cons are you must periodically buy new media. So every time you're buying new media, you're composting or trashing the old media. Upkeep on equipment is timelier than, say, deep water culture, because similar to NFT and the Dutch buckets, we have a small drip feeder line going in there, and that needs to be maintained on a routine basis, and you need to make sure on a daily basis that you actually have water coming out of every one of those inlets. Crop failure can happen quickly in a power outage situation. Again, it's very similar to the Dutch buckets and to our NFT system. NFT will happen quicker. These will hold a little bit more because they're completely wrapped, so it will hold some moisture, but nothing like a raft. So you've got a little bit of time to work, but you need to have some fail-safe measures in place. Varieties that work the best that you commonly see grown in slabs are vine crops. So tomatoes, cucumbers, squash, eggplant. I know squash isn't really a vine crop, but it's a bigger crop. Eggplant, capsicums, okra, many others. Lettuces and leafy greens can be grown by this method, though it's not generally economically feasible to do so. It's not going to be economically feasible to do okra or to do a lot of the other ones. Point is, we can grow pretty much anything in these, anything but, say, big root crops. But the cost of replacing these every time makes it not really worth it and not what we're going to do. Tomatoes, cucumbers, eggplants, those are 4-month, 6-month, year-long crops. So replacing the media once a year isn't a huge deal. Our last material we're going to talk about here is wicking mats. Okay, and method and how it works. A piece of material is laid flat and allowed to wick or absorb the water in which it sits in. Seeds are placed on top of the material and allowed to sprout. So think of a paper towel when you touch the corner to a spot of water and it pulls the water throughout the material. Well, it's wicking that water up. That's what I'm talking about here. The material can be burlap, that's very common, polyester fabric, many other types of fibers. It just needs to be able to wick water properly and be cheap enough to make it worth using. That's really my criteria. Some of the pros, self-watering as long as you keep a small reservoir or stream of water running to the mat. It's perfect for delicate crops like microgreens, sprouts, and animal fodder. Some animal fodder like barley you don't even need a media for, but for some fodder you do if you need a root structure, something to cling to start out. Some of the cons here, we got to periodically, again, replace that material after every crop. It can mold if left in stagnant water. and they're much more delicate. This is something you got to keep an eye on. If you have too much water, you can get moldy fungal issues. Too little water, they're going to dry out and die on you. So it's a little more particular because of the crops we're growing, but that's just the nature of the beast. Varieties that work best, again, all sprouts and microgreens. Now I did this really quick, just in a few days, to show you these are radish sprouts, but just to show you what it looks like, I cut a piece of this polyester material, fabric, laid some sprouts out on it, and let them sprout up. And this way you can see the actual material around the outside. Now, in a grow-out situation, we just do the whole trough. We're not going to see the material. But here you can actually see the roots penetrating through the fabric, nice bright white roots actually going into these little channels in the bottom of this trough right here. And here you can see a couple different types of microgreens here grown on those mats, but you can't see the mat because they're so full of the actual types of sprouts. And here you can see once it's picked up, you don't even actually see the mat inside. It's totally enveloped by the root system of, these are actually a snow pea sprout. But they've totally enveloped that, and you can see it's a beautiful, beautiful product there. And that's it for this session. Again, if you have any questions at all, please email me, ryan@collegeofaquaponics.com, and I will be sure to cover those questions in our weekly question and answer session and make sure you get all the information that you need. Thank you very much.